Today, I am once more joined by James Loach, Head of Research for Senseye Predictive Maintenance, as we continue to discuss the ways that Senseye is applying artificial intelligence to predictive maintenance and to the way that users and engineers can interact with information, data, and machines themselves. So, kind of to pick up where we left off in previous parts of this conversation, is there anything else that kind of makes Senseye unique compared to other predictive maintenance platforms, would you say?
I think the general purpose nature of Senseye is quite unique. I mean, people try to do it, but Senseye, it was of interest to Siemens when we were acquired because of some demonstrated ability to do this, right? Accounts over 10,000 assets, right? And then the decision support thing. I mean, I don't think I would say anything other than those things, right? But I think it's, it's interesting. It's that. And I think in general about Senseye, it's just being very clear-eyed about the world, right? Then what we're trying to do, we are not about doing deep learning to do magic, in quotes, right? We're building this very practical, reliable, dependable system in the way that I've described. That, easy to set up, easy to use, scalable, and kind of does the thing, right?
Something you'd be interested in deploying on a big scale rather than as a proof of concept to show people that's like, this is what you could do with AI magic, basically.
Yeah. And it's strange. It's like, I don't know, you talk about ways to describe this, but there is a sense in which we do the boring stuff, right? Okay, in a somewhat boring way, right? It's the idea is it is a reliable, solid colleague, right? And through acting in that way, does provide real value, and it doesn't just do the magic thing on 1% of your assets, where the thing happens to have been trained properly or, happens to work in some particular situation, right? Yeah.
Right.
Anyway, but it's interesting. It's the scalability does. It's strange. It's just what I said, really. It's like, but language models make this great, right? Because you make these pragmatic decisions, organize things in this pragmatic, sensible way, and then you just got this pot of magic to spread over the whole thing, and it just works, right? You know what I mean? In a very nice way.
Yeah. So, do you see these type of kind of general recommendation and conversational systems kind of shifting the modern design or the modern decision paradigm that's being used in other industries elsewhere in general?
Yeah, I don't know. I mean, the criticism of Senseye would be its decision support nature. There's sort of like it could appear to be sort of like a non-precise approach to things, right? And very, very general and like whatever, all of this kind of stuff, right? And of course, in some sense, people would just like numbers or facts from their system, right? And no fuzziness, right? But it's I don't know. I mean, I hate to say, I mean, ChatGPT is the obvious thing at the moment where you have something which has phenomenal powers, right? Okay, and this ability to interact with it in this very, very naturalistic way, work through problems and get really amazing things done, but at the same time, is not in some sense like 100% reliable, right? It's kind of human-like in that sense, and obviously people with ChatGPT have some tolerance of this, right? Like the advantages you get from that paradigm like clearly outweigh, right? Like it might give unreliable mushroom identifications, right? Or it might do this kind of strange, dangerous things in some way, right? But it's very good for doing your homework or writing this letter or whatever, right? Like it's clearly worth it, right? The fuzziness, and with that technology, the fuzziness kind of has to be there at some level, right? It's just the way it works, Anyway, but this is another reason its language was this kind of nice fit for Senseye, right? There is an intrinsic general kind of fuzziness to our system, right? That gets smoothed and actually even sharpened up in some way by the use of language models. And the existence of these kind of like non-perfect advisory systems, if you know what I mean. I think it encourage people to be more comfortable with that kind of thing, right? And it's just so natural. It's just what humans are like, isn't it? Like, even if you trust people and they do a great job, I mean, there's still the edge of fuzziness or unpredictability, Anyway, whatever, right? I think people are more
it's just kind of the
more accepting of that.
The basis for the way things are. It's like in the real world, things are a little fuzzy.
Yeah, but I think people just become more accepting of that. I think these kind of systems, certainly B2C things, obviously, right? But also in these business settings, technical settings as well, right? Anyway, that's it.
Right.
Sort of see thing.
Yeah. So, do you see predictive maintenance kind of becoming the standard moving forward? Either kind of the version that the academic version you've talked about, or the version that Senseye is using, the more general one? And if so, what would be some of the challenges you would see with like moving this to a kind of a global scale, so to speak?
Yeah, I mean, I sort of can speak to some of the issues that Senseye have, right? I mean, customers are like not very good with sensors and data, right? Like this is just a very profound issue, right? Like no sensors as a first problem, and then random sensors after that, producing random data, right? Going into random places that you have to try and get the data out of, and et cetera, right? So I would say connectivity is still our biggest issue, right? And it's all very well having a system that can produce results very quickly and all the things I described, right? But it takes 6 months to persuade someone to give you the data, right? Even after signing the POC, right? Anyway, so I think access to data and organization of data is clearly a big issue, right? Again, I think the advances that you're seeing in AI, I see them just, well, I hate to say, right? I mean, you can imagine a system like Senseye in the way that I've described, being kind of supercharged and sharpened up, right? Like, well, I hate to say, right? I mean, like I was talking about, with the conversation, right? In the past, like our AI has, not really have any concept of machines, right? Or how they work or things like this, right? But, by language models in our case, that kind of general knowledge is just immediately available, right? And you can obviously connect that up to more specific knowledge like the manuals and things like this. And so very rich contextualization, and then also the ability to do the data transformation. So we also work on tools for automating that, right, in this kind of conversational way. And then eventually you would want the system to be looking at the data and seeing what's been done before and using its general knowledge and just being sensible about it, right? And taking away the need for any human effort there at all, right? So I suppose you could imagine general purpose systems like Senseye becoming higher performing, right? Just due to this greater availability of context and greater support, intelligent support for users and things like that. It doesn't help with the data connectivity issue, but everything past that should sort of become easier. I don't know. And then I suppose
it's kind of the benefiting from the general digital transformation of everything.
Yeah. But more specific models, I suppose you could imagine building systems that make it easier for you to train and deploy things that are more like custom models. You know what I mean? So you could try and take that difficulty away, right? So you could imagine something like Senseye that maybe organize as some kind of automated data scientist, right? That you know what I mean. So you could potentially de-skill, right, some of that expensive specialist modeling. You know what I mean, right? I don't really know where all this goes, but I know that it changes very quickly from here on and gets a lot easier. Whatever your approach is, right? I think.
Right. So kind of we're at the cusp of everything being more accessible, more data is available. There's less need for copious amounts of manual labor and having tons and tons of expert knowledge to get your system working and running. And it's kind of at a point where it's maybe even a little hard to say where things are going to go in the future, because things are still changing so quickly, and with advances are happening so fast and all that kind of stuff.
Yeah, definitely. And there are certain areas which are like kind of ripe for people to do work in, where not much work is being done at the moment, like time series foundation models. There's a lot of image stuff and audio stuff and text, obviously, but you should be able to do these kind of things. Well, obviously you can, like with time series and connecting time series with words, right? And yeah, that's just a very interesting thing, right? So being like when our system, in the language model experiments that we do, we have to kind of describe the time series, so you're finding different sections of it and calculating parameters and characterizing them, or this is a little trend of this size and what have you. And then the intelligence in the system is using that kind of picture, like it's, these fragments of information about things, right? And then trying to correlate those with textual descriptions, things that have happened, But I think obviously it's possible to give these kind of models a more natural understanding of time series, right? Okay, with the meaning of that folded in, and yeah, it's very interesting where that would go, right? That's very important for predictive maintenance, right? Given the nature of that.
Yeah, of course. So I guess before we kind of wrap this up here, is there anything else interesting you'd like to talk about kind of in the realm of AI, either within Senseye or Siemens, or kind of in the field of AI in general?
Yeah, I don't think so. I mean, I think we're all the same, right? Everybody's very enamored with what is happening in AI at the moment. And, in my head, I guess many people's, it first feels like the first like a baby steps of artificial general intelligence. These systems available have that kind of character, in this very, very basic form, right? Obviously. I won't repeat what 1,000 other people have said, right? But it's obviously a fascinating time, in AI, machine learning. And yeah, it's just very interesting how it will play out. But I think how it plays out will play out quite quickly, right? And yeah,
absolutely,
it's a wave to ride, I think, right?
Yeah, we're really kind of at the AI revolution right now. Everyone's really excited about it, but it'll be interesting to see where things go over the next few years, even the next few months, with how fast things are advancing.
Yeah, no, it's strange. I mean, I guess like lots of people, it's like early this year, I have trouble sleeping at night because of how fast my field was advancing, right? It's like, it's difficult just to keep up and comprehend what was happening. That has slowed down a little bit, right? But yeah, it's still extremely fast compared to my old world in particle physics, right? Where, changes happen, very slowly, decade to decade, right?
Sometimes it feels like things are advancing minute to minute in the world of AI. It's crazy.
Yes, yeah, indeed.
All right.
Cool.
Well, I think that's going to have to be where we end this episode here. So I'd like to thank you, James, for joining me here today. It's been a pleasure talking to you.
Yeah, it's been very nice to be on the podcast and talk to you, even though I guess I talk for 95% of the time. Right? But, I'm pleased we got to do this, and yeah, obviously anyone interested in Senseye, if they managed to stay this far, right, is welcome to get in touch, and happy to talk, right?